are many forces in our daily life. So, let we discover about force. First, we should know what is force. Force is defined as physical quantity which causes an object to move, stop, change its direction, or change its physical form. A force is also defined as push or a pull on the object. It is a vector. It has both a magnitude and a direction. A force requires an agent. That is, a force has specific, identifiable cause, which means something does the pushing or pulling. A force is either a contact force or a long-range force. The SI unit of force, F, is kilogram meter per second squared or Newton. Now, let's move to the types of force.
Weight is defined as the force exerted on a body under gravitational field, on or near the surface of the Earth. The agent for the weight force is the entire Earth. The direction of the force is always points vertically downward. The equation is weight equal mass gravity. The symbol of weight is W.
Now, I'll explain about tension. When a string or rope or wire pulls on an object, it exerts a contact force that we call the tension force. The agent for the tension force is string or rope or wire. The direction is always in the direction of the string or rope, which is away from the object. Same string possess same tension.
Normal force is defined as a reaction force that exerted by the surface to an object. The agent for the normal force is the surface. The direction is always perpendicular to the surface, and the symbol is N.
Now, I will tell you about friction. Friction is a force that opposes the relative motion of two surfaces in contact. The agent for friction is rough surface. The equation for friction is coefficient of friction is ratio between frictional force to normal force. There are two types of friction, that is static friction and kinetic friction. Static friction is a force that keeps an object stuck and not moving, where the velocity is zero. Kinetic friction is when object moves across a surface, or a force that opposes the motion. The magnitude of static frictional force can have any value from 0 to maximum value. Static friction opposes the impending relative motion between two objects, while kinetic friction opposes the relative sliding motion that occurs. The value of kinetic friction between two surfaces is less than the value of static friction.
Last is external force. External force is a push or a pull on the object. The direction of external force are given in the question. The symbol for external force is capital F.
Now, we go to how to identify forces. First, we must identify the system and the environment. The system is the object whose motion you wish to study. Environment is everything else. Then, draw a picture of situation. Show the object and everything in the environment that touches the system. After that, name and label each force acting on the object. There is at least one force at each point of contact. There may be more than one.
Now, I will show you how to draw a free body diagram by following the step. For this example, a box of mass m is pulled along a horizontal surface by a force applied at an angle theta above the horizontal. Assume that the surface is rough. Draw a free body diagram of the box. For the first step is you need to identify all forces on the object. So based on this diagram, you can identify friction since it's on the rough surface, normal, weight, and force. So proceed to the second step. You need to draw a coordinate system. So you need to draw x-axis and y-axis. So for the step 3, you need to represent the object as a dot at the origin coordinate axis. So here's a dot. And for the last step, you need to draw the vector for each of identified force. So based on the diagram, we have friction, weight, normal, and force at an angle theta. So you have friction, normal, weight, and force at an angle theta. And your free body diagram is done. So let's proceed to the next information. Go.
Newton's first law is an object that is at rest will remain at rest, or an object that is moving will continue to move in straight line with constant velocity if and only if the net force on the object is zero.
Newton's second law. The rate of change of momentum of a moving body is proportional to the net force and is in the same direction as the net force acting on it. It can be represented by
The last law of motion is Newton's third law. Newton's third law is every action force has a reaction force that is equal in magnitude but opposite in direction. If two objects interact, the force F12 exerted on object 1 by object 2 is equal in magnitude and opposite in direction to the force F21 exerted on object 2 by 1. Note on notation F12 is the force exerted on 1 by 2. As the example, when you push on the wall, it will push back with the same force. Or when the book is placed on the table. The normal force on the book by table is the reaction of the force the book exerts on the table, weight.